Hello everyone. So today we'll go over 5.1 angle measure. First of all, we have to know what is the mean of angle. Anyone knows what is the mean of angle? Angle measure. Did you know what is the mean of angle? Okay. Angle is we can make an angle between by making like two rays. So it's two rays R1, comma R2. Both of them are intersect at a point. This point is called the vertex. Okay, so R intersect at point. This point again called vertex. And I can denote it by O, vertex O. So the angle is two rays, R1 and R2, are intersect at a point. This point called a vertex. So here is the R1. Suppose this is my R1, and this is my R2, and these two rays are intersect at this point. This point is called O, vertex. This point is called O, vertex. And again, this is called R1 here. This is R1. This is R1. And this is R2. So this called vertex here. I call it vertex. Vertex. R1, R1, R2, and the vertex O. So my angle, it is between R1 and R2. This is my angle. Here we have a point in this ray. We call this point A. And also we have a point here in this ray, R2. It's called B. So I can call this angle as the angle of AOB. The angle of AOB. This is my angle called. We can call this angle as AOB. Okay. We have some like notes. The first note is here. If I start measure the angle from R1 to R2. So again, if I start measure the angle from R1 to R2, and it's look like here number one notes. Second. So R1, we're going to call R1 as initial side. So here we call R1 as initial side, and we call R2 as terminal side, and R2 as terminal side. So this is very important because we're going to use it a lot during this section. Terminal side, initial side, and terminal side. So initial side, R1 called initial side because we start measure the angle from R1, and R2 called as terminal side. Terminal side is here. This is my terminal side. This is my initial side. So R1 is the initial side. Why? Because I start measure this angle starting from this point. This point is in R1. So this is my initial side. And I end measuring this angle at this point. This point, because it's lying, or the side of this point, it's in the R2. So R2 called the terminal side. Does it matter which side is initial and which side is terminal? Yes, Bilal. It's matter, because if I start measuring the angle like this, look, here is the green. Start measuring the angle like this. So R2, we're going to call it the initial side, and R1, we're going to call it the terminal side. But because we start measuring the angle from this side to this side, so R1 called the initial side and R2 called the terminal side. Okay, Bilal? So R2 here, the terminal side. Okay. And note number 2, we should to know. So the angle will be positive. So the angle has two sides. Sometimes it's positive, sometimes negative. So the angle will be positive when, if the rotation, this is very important, the rotation for measure the angle counterclockwise. Okay. So if the measure of, if we go to measure the angle and the measures like the angle like has rotation counterclockwise, the angle will be positive. So what does that mean? Here is my angle, suppose. What does that mean of, first of all, what does that mean of counterclockwise? So here is my Cartesian plane, for example. And if my rotation is counterclockwise, means like this. First of all, clockwise like this, counterclockwise like this. This is counterclockwise. So counterclockwise, the measure of the angle will be positive. So in my example here, the angle AOB is positive. Why? Because my rotation is counterclockwise. From this side to this side is look like this, and this is counterclockwise. This is mean the angle AOB is positive, has a positive measure, has a positive measure. But if I start clockwise, clockwise mean something like this. If I measure the angle like this, so the angle has a negative sign. Okay. So here we have to focus for counterclockwise, and we have to focus will be positive. So positive counterclockwise. Any question? Any question for this? Okay, this is what you should know. Now I'm going to give you like an easy and simple example to show you how this, what does that mean by using like talking about these notes. So my example is the example, if I have here. If my angle goes from R2 from R1 to R2 like this. My angle rotated from R1 to R2, and the graph for R1 and R2 as the following. Here is my R1, and also here is my R2. This is my R1, this is my R2. So first of all, we should to know the angle should be, first of all, we have to know the angle should be from R1 to R2. So this is my angle. Because I start at R1 and I end at the angle at R2, this means the angle should be from here to here. And I have to know this is the point here called the vertex O. This is vertex. This vertex is O. And if I want to call this angle, I have to get a point in the R1. I'm going to call this point A. And I have to get a point on the R2. I'm going to call this point as B. So the angle AOB. So my question now, what's my initial side? Is it R1 or R2? What's my initial side? This is the first question. R1, exactly. Why? Because we start measuring the angle from R1. So here R1, it is R1 is my initial side. And also I have to know what is my R2 from the graph. What's my R2? Is my, what I have to call R2? Terminal, exactly. It's my terminal side. So R1 is my initial side and R2 it's my terminal side. Now my question is, second note, what's the sign of this angle? Is it positive or negative?
Is it negative?
Negative, exactly. Why?
Because the angle is counterclockwise.
It's counterclockwise or clockwise? This is counterclockwise, the opposite of the clockwise.
Okay, yeah. So then it's clockwise then.
Clockwise, the clockwise like this. So because the angle we measure it here, it's clockwise, so the angle has a negative sign. So the angle clockwise, so negative angle. So this angle must be negative, like negative 30. If it's the angle has a major 30, so the angle has a negative sign, so it will be like negative 30 or negative 50 or negative 70, whatever the angle is, must be negative because the rotation is clockwise. Because the rotation is clockwise, so the angle has negative measure. It will be negative 30, negative 40, negative 120, negative 150, whatever the angle is, so must be negative. Any question for this? Now we're going to learn how we can convert between degree and radian. So third things we have to know here in this section is converting from degree to the radian and from radian to degree. Convert between degree and radian. convert from degree to radian. So first of all, we have to know 180 degree, it is by radian. We should to know 180 degree must equal, so here 180 degree is equal by in radian. So this circle, small circle called degree, and this by this red means radian. Okay, the red here means radian, and this small circle called degree. So 180 degree equal by radian. So to convert from degree, here degree, we're going to radian. So here we have to multiply this, multiply the degree. We must multiply the degree. Here we have to multiply the degree by over 100, by over 180, I mean 180. So we have to multiply the degree by this. Now to convert from radian to degree, the opposite side, we have to multiply the radian by 180 over pi. So I'm going to give you example for the both of them. So I'm going to take this up a bit. Okay, and this up like this. Okay, this is a little bit up. One second. Okay, so my example now, express the 60 degree in radian and also number 2, this is number 1. Second one, express the pi over 6 in degree. Second one, express the pi over 6 in degree. So here it's pi over 6. So for the first one is 60 degree. Here's the degree. We have to put the sign or symbols here, and here is pi over 6. Here, pi over 6. Okay, who will do the first one? Who will do the first one? Who will do the first one? Okay, for the first one, do we multiply 60 by over 100? Yes, this is correct. So for the first one, we have to multiply the angle 60 times by over 100. So we have to remove the 60 by 100. Here I will get 1, and here I will get 3. So by over 3. Again, so the first one express the 60 in radian. So the 60, it's degree. We have to convert it to the radian. So this is mean we have to multiply by over 100. Yes, in degree, we have to multiply by over 100. So here is degree, so you have to multiply by over 100. 180, I mean, 180. So the 60, we can cancel the 60 with the 180. So the 60 with 180, here is 1, here is 3, so I will get by over 3. Okay. For the second one, who will do the second one? From radian to degree.
I'm gonna try, but do you like do you do like pi over 6 equals to
By
1
over
over
6,
6? Do you do like equals to 180 over pi and then cross multiply?
multiply by what? What we should to multiply this?
One
If over
180
what?
over pi.
Exactly. So to changing from radian to degree, we have to multiply the radian by 180 over pi. Now we can cancel the pi with a pi. Can cancel the 6 with 180. I will get now 30. I get 30. 30 times 1 is 30, and 1 times 1 is 1. So the answer is 30. 30 what? Degree. Here, pi over 3 radian. Rad. Yes. Pi over 6 by 100. Yes, Bilal, this is correct. Well, it will be pi over, yes, correct, Layla. Michael, the same thing is correct. Okay, now for this is what you should to know, how we can convert between degree and radian. Now, the angle in the standard position. So we have to learn what is the meaning of the angle in the standard position. So angle in standard position. So what is the meaning of angle in standard position? So if here, if this is mean the initial side must be in the positive x-axis, and also the vertex must be in the original point. Origin point means the 0, 0. So if the angle, if the initial, so here I can said if the initial side in the positive x-axis, this is the first condition. The initial side, this is mean where I can start measuring the angle. If it's in the positive x-axis in the Cartesian plane, and the vertex O at the origin. The origin is 0, 0, comma 0. So at 0, 0. So here I'm going to like the important two condition here is the initial side at the positive in the positive x-axis. So here, this is the first important condition. And the vertex or at the origin. Okay, so here I have like some example for the angles in the standard position. Suppose here's my, this is my positive x-axis. This is my, here's my x-axis, I mean, this is my y-axis. So I have like 4 example to show you the angles in the standard position. This also, and also this. So for the first one, the angle, my initial side is this side. So this is my initial side here. Must be, my initial side must be on the positive x-axis. So this is my initial side. And also my terminal side can be in the first quadrant or in the second quadrant or in the third quadrant or in the fourth quadrant. Doesn't matter where is the terminal side. No, sorry. Thank you. So for these things here, it doesn't matter where is the terminal side. So this is my initial side. The initial side must be in the positive x-axis, and for the terminal side, doesn't matter where is it. So suppose my terminal side is in the first quadrant like this. So this angle here, this angle, it's in the standard position angle in the standard position. Why? Because the initial side, it's in the positive x-axis, and also the vertex, it's at the 0, 0. This is the 2 important things. Here is the initial side, and this is the vertex. I'm going to call the vertex by the letter V. Here the initial side by the letter I. So for the second and the third one. So this is my angle. My angle is this one. This is my angle. Now for the second one, so some example for the standard position. Suppose, so always the initial side, it's in the initial side, always it is in the positive x-axis like this, always in the positive x-axis, and my terminal side in this example, it will be in the second quadrant, so it will be like this. And also I need this angle measure like this. Suppose my angle not from here to here, it will be clockwise like this. So this angle must be negative. This angle is theta, and this angle should be negative angle. Again, this angle it's in the standard position. Why? Because the initial side, it's in the positive x-axis. This is my initial side I, and this is my vertex. The vertex, it's in the origin 0, 0. Okay. Now for the third one, so the same idea, but here the angle has different shape. So here is my initial side, always in the positive x-axis, and my vertex is at 0, 0 as usual. Now suppose my uh, terminal side is here like this. This is my terminal side, but my angle in this time, it will be has different shape like this. It goes like that, 360, then goes back to the initial side. So this angle has a measure greater than 360y, because this angle rotated around the XY plane 360, then we move to move up a little bit to the initial side. So this angle has a measure greater than 360, and the position the sign of this angle has positive angle y because it's counterclockwise. And the last one, so this is my initial side, always my initial side, it's in the positive x-axis all the time. So this is my initial side, this is my initial side, and also my terminal side, it's in the fourth quadrant like this again. Oh, by the way, I forget to write here I, the initial side here. This is my initial side, this is my initial side, and this is my vertex. This is O, and this is my O here. This is my O. Now this is my initial side, and this is my terminal side, and this is the point O. But the important things, the angle here, this is O. The angle here, it's rotated clockwise, counterclockwise around, counterclockwise like this. So, but this different about the before. So starting like this, turn around 360, we stop here, then we continue turning until we stop at this point. So this here I get a question for the top right degree. Why cannot be counterclockwise? This is clockwise because as you see here, the angle, look, turn around like this side, starting from, so this is my x-axis, this is my y-axis. If you see for this one, the angle has a measure like this, starting at this point, turn around like this. And when you turn around like this, it's like clockwise. Clockwise has a negative measure. How do you know how much it goes? Okay, so this one, it's acute angle. Acute angle, it's like, will be like less than 90. Any degree when you turn around the XY plane, so the first turning, the first rotating from this initial side, rotated around the XY plane until this point is 360. Then this is acute angle. The angle must be less than 90. I will show you in this graph. So the angles, so I will show you some angles. If my graph like this, my initial side at the positive x-axis like this. Hold on, but let me show you the fourth. So this is, hold on 1 second. XY plane. If my initial side, it's in the all of them, the initial side, it's in the positive x-axis. Positive x-axis, positive x-axis, x-axis, and positive x-axis. So any angle, so you should to know the angle here should be 90 degree. The angle like this should be 100 degree. 180 degree. The angle like this should be 270, and if you turn around the same things will be 360. So the angle here, this angle is 90 degree. 90 degree, to convert it to the radian, as we learn here, if you want to learn how like 90 degree to convert it to radian is, to convert this in radian, it will be like pi over 2 radian. This angle is 180. This is 180 degree. Always, you should to memorize this. And 180, to convert it to the radian, it must be pi. Because 180 times pi over 180, you can cancel the 180 in the numerator and the denominator, and you will get pi only. Degree here, if you rotate like this, the degree will be 270 degree and has 3 pi over 2 radian. And for this angle, is we rotate it around the xy plane, and this is 360 degree, and this is equal to pi radian. Sandra, can you go back here? You're welcome. So these degrees, we must to memorize all of them, okay? So we should to know all of them. Okay, so again, this is 90 degree, this is 200, 180, 270, 360. Any question? Now we're going to learn how we can find the coterminal angle. Coterminal angle. Coterminal angle. So first of all, angles. First of all, we should to know what's the mean of coterminal angle, definition of coterminal angle. So the mean of coterminal angle, I can say here, any two angle in the standard position. What is the mean of a standard position? Anyone can remind me what is the mean of standard position? As I said before, one slide before.
The vertex has to be at 0, 0, and the x, or the initial side, has to be on the positive x axis.
Yes. Thank you. This is correct. So, and the initial side, like he said, Chris, what's your name? Can you spell
I'm
it?
Caesar.
Caesar. As Caesar said, the initial side must be in the positive x-axis, and the vertex must be at the point 0, 0. So suppose I have two angles in the standard position. We said both of the angles are coterminal if, here is the condition, their sides. What is the mean of their sides? Which side? Here I mean. Their sides coincide. What's the mean of their sides? Their sides here I mean the initial side and the terminal sides. Both of the initial side and the terminal side are coincides. I will give you example for this, how we can find the coterminal angle. I'll give you example how we can find the coterminal angle such that the initial side is coincide and the terminal side are also coincide. So my example is look like this. Find, number one, find angle that coterminal with angle theory in standard position. So first of all, the angle has degree theory. The degree theory must be in the first quadrant. Why? How I know this? Because as I told you in this graphs, look, from the initial side here in this position to the terminal side, the degree is 90. So the degree theory, it must be less than this. It's supposed to be like this. This is my initial side and this is my terminal side. I mean, for this, I will show you here in this graph. So my angle here is 30. This is mean, if I want to graph this angle, this is my initial, first of all, this is my Cartesian plane, x-axis and y-axis, and my initial side must be in the positive x-axis. Must be in the positive x-axis. Here is the positive x-axis, and the vertex is at the 0, 0. So this is my initial side, I. And the angle theory, it's less than 90. The angle 90 is here, the y-axis. But I need the angle theory, it's acute angle. It's supposed to be here. This is this is the angle theory. Okay, so here is the angle theory. This is here theory. This is 30 degree. So my question is, find angles that coterminal with this angle. How I can find a coterminal angle? If I add this angle to the 360, I mean like rotating this around the XY plane, I will get the same angle as both of the initial and the terminal side are the same. I mean, for this, my angle is 30, right? So to find the coterminal angle, just I have to add 360 to this angle. So when I get 360 degree to this angle, I will get 390 degree. And if I want to graph this angle, so let me remove the 30 here. This is 30. So the 360 means I have to rotate around the XY Cartesian like this. This is 360 until this point. Now I have to continue by 30. Here is the 30. This angle is 390. This is 390. But the small one is 30. Again, I start from this point, the initial side, rotate around the XY around the Cartesian plane, XY plane until this point. Then I get 360. From this point to this point is 360. Then I have to add 30 by moving a little bit up. I will get 390. So this angle actually is a coterminal angle to the angle theory. And also I can get a lot of angles are coterminal. So if, for example, adding also 360 to this angle, I will get another coterminal angle. So this is the first coterminal. Second one is 330 plus 360 plus 360. What I will get here? 30 plus 360 is 390. And 390 plus 360, how much? How much? Any idea? How much 360 plus 360 plus 30? 750, correct. Thank you, Bilal. So again, this is my Cartesian plane for the second one, and this is my initial side. This is my okay. This is my terminal side. This is 30. It's 30 degree. Here's the 30. Now 1 second. Here's the 30 again. So I can get another angle coterminal to the 30 is 750. I mean, for 750, I have to rotate it around the XY plane 2 times. This is the first time. Here is 360 until this point, 360. Now again, 360 one time. There is another 360. Now I have to rotate the 30. Here is the 30. So from this point to this point is 360. From this point to this point is 360 plus 360. And from this point to this point is 750. Any question? So the angle here outside is 750 and the small one is 30. -750. So the same things for minus. If I want to subtract, so I can get another coterminal angle by subtract 360. So 30 minus 360. Now, what is the answer? Is minus 330. Correct. Minus 330. This angle is also coterminal for the angle 30. I want to graph this function, this angle. So this is for here, this is for the first one, and here is the third one. Here's my initial side. This is my initial side, and this is my terminal side is 30 degree. Okay, now 300 minus 330. So I have to start from the initial side. So this is first of all 30. This 30 degree. Now minus 330. I have to start from the initial side. Then I have to rotate in the, because it's negative, this is mean I have to rotate clockwise like this until this here, because from here to this point it's minus 180. From this point to this point it's minus 180. Why? Because look here, from this point to this point is 180. But if I rotate from in the opposite side, will be minus 180. If I rotate it from the positive side, like clockwise, will be minus 180. And the same things here. From this point to this point is 270. If I rotate it in the different way, I mean like this side to this side, but if I rotate it different way, will be negative 90. I will teach you for this. So here I have the angle From this point to this point is minus 180, and here we have also another minus 90, and from here to here it's 30 minus. So this is minus 30. Actually, this is minus 90 from this point to this point. From this point to this point is minus 180. So the summation for minus 180 with minus 90 with minus 30, it's minus 330. Any question for this? That's why this angle from this point to this point in this rotation is minus 330. Okay, another example. This is part one for the example. Now part two, question number two. Okay, question number two. Here two. And the angle, it's not in the degree. Now it's in the radian. So here we don't have 30 degree, we have pi over 3 radian. So the angle here it's pi over 3. So the same things, pi over 3, we should to know it is less than pi over 3. It's actually, if you when I convert it, it is, we have to multiply it by what? If I want to convert this to degree, it will be by multiplying of 180 over pi, and the answer is 60. So this angle actually is 60 degree. So again, this angle is less than 90, less than 90. This is the right angle. So it's less than 90. So it's supposed to be in the first quadrant. So angle, the angle here. So this is my x, the x coordinate, the x-axis. This is my y-axis. And the angle, it's in the standard position, like I said before. So it's supposed to be here. So the angle must be here in the first, in the positive x-axis. So the angle has initial side in the positive x-axis, and the terminal side must be in the first quadrant. I mean here, must be here. Why? Because it's less than 90 degree or less than pi over 2. Because the 90 degree, like I said here, it's pi over 2. So pi over 2 is greater than pi over 3. Pi over 2 is greater than pi over 3. How I know? I have to make the denominator r equal by multiplying this by 3, by multiplying this side by 3, by multiplying this by 2, by this by 2, and multiply this by 2, I will get 3 pi over 6 is greater than 2 pi over 6. Now the denominator are equal. Look, the numerator 3 pi, here I have 2 pi, so 3 pi over 6 is greater than 2 pi over 6. So the angle pi over 3 is greater than, less than pi over 2. So this is mean it must be in the first quadrant like this. So this angle, it is pi over 3. Pi over, this angle is pi over 3. Okay, now how can I find the coterminal? By adding what? I have to add 360 degree, but here is radian. What is the convert of 360 to the radian? What's the convert from 360 degree to the radian? 360 degree. I want to change it to the radian. How much radian? Question mark. radian. 2 pi, correct. Thank you, Bilal. So 360, we have to multiply it by pi over 180. And 180 cancel with 360. I will get here 1, here I will get 2. This is equal to pi, correct. Now I can add pi over 3 plus 2 pi. How much I get here? So I have to make the denominator equal. Here is over 1. So this is mean I should to multiply both sides here by 3, multiply by 3. Now I will get what? So I have to multiply both sides by 3. This is by 3 and this is by 3. This is equal pi over 3 plus 6 pi over 3. And this is equal 7 pi over 3. So if I want to, this terminal, this angle is a coterminal to the angle pi over 3. This angle is a coterminal to this angle. So if I want to graph this angle here in the first one, so I have to move from this point, starting from this point, turn around 2 pi. This is 2 pi. I stop here. This is 2 pi. Then I have to move or rotate it by pi over 3. This is the pi over 3. Stop until here. This is 7 pi over 3. Any question so far? Any question for this? Okay, second, no questions. Okay, so for the second, if I want to find another coterminal to this angle, I can what? I can subtract, not just adding, or I can add another 2 pi. So I can add another 2 pi, or I want to, in this one, subtract 2 pi. So the same idea, I have to make the denominator equal. This is equal pi over 3 minus 6 pi over 3. Now, if I want to subtract, this is 1 minus 6 is minus 5. Exactly. Thank you, Bilal. Minus 5 pi over 3. So the same idea, instead of rotating, the rotation is counterclockwise, it will be clockwise. So here is the graph of this angle. So here is my Cartesian plane. This is my x-axis, and this is my y-axis. Here is the positive x-axis, and also the negative, the initial side. This is my terminal side here. This one is my terminal side. So the angle is look like this. Starting from the initial side, at this point, rotated like this. From this point to this point is negative pi without anything, negative pi. From this point to this point is negative pi over 2. And from this point to the initial side is negative pi over 3. If you do summation of minus pi plus negative pi over 2 plus negative pi over 3, you will get this number, minus 5 pi over 3. And this angle is coterminal to this angle. This angle is a coterminal to this angle. Also, this angle is a coterminal to this angle. This is very important. Any question? Okay, if there is no question, I have another example. My example now, this is very important example. Find an angle with measure between 0 and 360 that coterminal with the angle of measure 1290 in standard position. Find an angle with measure between 0 and 360 that coterminal with the angle of measure 1290 in standard position. So the idea for this question, to solve this question, we have to keep subtracting this angle because it's a large angle, right? We have to subtract this angle. We keep subtracting this angle by 360 until we get an angle. This angle is between 0 and 360. And this angle is a coterminal to this angle. Again, we have to keep subtracting this angle by 360 until we get an angle between 0 and 360. And the angle that we find it between 0 and 360 is a coterminal to this angle. So the first step, I have to subtract 1290 of what? Of 360, like I said. What is the answer? What is the answer of 1290 minus 360? 0 minus 0 is 0, 9 minus 6 is 3, and 2 minus 3 is not possible, so 12 minus 3 is 9. So the answer is 930. Okay, this angle is not belong to the angle between 0 and 360, so this is not my answer. So I have to subtract this from 360 again. 930 minus 360. What is the answer? 0 minus 0 is 0. 3 minus 6 is not allowed. So 93 minus 69 is 570. Correct. Is it between 0 and 360? No. This angle is not between 0 and 360. This angle is a coterminal to 1290, and this angle is a coterminal to this angle. But this is not my answer for this example. The example is looking for angle between 0 and 360. So I have to subtract again this angle from 360. 570 minus 360, how much? 0 minus 0, again 0. 7 minus 6 is 1. 5 minus 3 is 2. Is this angle between 0 and 360? Is this angle is between 0 and 360?
Yes.
Yes, this angle is between 0 and 360. So this angle is a coterminal to 1290. So this angle is my solution for this example. So the coterminal angle is 210, is between 0 and 360. Is it clear? Any question? Anyone has a question? Okay, let's go now to the last two things in this section is the length of the circular arc and the area of the circular section. And both of them are so easy. They have just a formula. You have to apply, applying for this formula for both of the formulas, and they are it's not complicated a lot. So the first one is the length of a circular arc. The length of the circular arc. So we have the circular arc. I mean, for this, we have a circle like this. And we have a point, center. Yeah, I can go back here. Okay, this circle has a center like this. It has a radius. This is my radius. And also it has another radius here. This here called a circular arc. This here, I mean, this one is called the circular arc. I need to find only this length from this point to this point. This is my goal in this part of the section. I need to find the length of S. I need to find the length of this S from this point to this point. And but we have two given. The first one is the radius. This is the radius from this point to this point. And also the second given is the theta, the angle. This theta must be in radian, must be this theta in radian. If I give you this theta as in in degree in the exam, you have to change it to the radian. You cannot plug the degree inside the formula. The formula for this is S equal R, the radius, times theta. And again, this theta must be in radian. This is called the length of the circular arc. You have to use easy and simple formula to find the length for S. You have to multiply the radius by the angle theta. But for the area of the circular section, the area of circular section is given like this. Suppose I have a circle like before. Here is my circle. And also this circle has a center. Oh, this point is center. And also it has a radius. This is my radius. And also this radius has theta with this angle. And my goal is to find the area, this area. I have to find only this area. This is my goal. I have to find this area only. Okay, so first of all, there is two things given. First of all is r, the radius, and the second one is the theta and r. So to find the area equal, we have to use this formula, area equal 1 over 2, I mean 1/2, times the r, the radius, square. We have to square the radius times the theta. And here the theta again, it's in the must be theta must be on radian. Or I can say theta is must be radian like this. I mean, this theta, we have to convert it to the radian. Cannot plug it inside the formula direct. We have to change it to the radian. Then we can solve the question. So I'm going to give example. So the example is find the circular. I will go back. Hold on 1 second. Find the circular arc and the area of the section for circle has radius 10 and angle 30 degree. Here you go, Daniel. Okay. Now find the circular arc and the area. I need to find these things and the area. Second things of the section for circle has radius 10 and angle 30. So the circular arc formula is here. S equal R times theta. Theta must be in radian. What is the angle here? It's 30 degree. How can I change 30 degree to the radian? What I should to multiply?
Is it pi over 180?
Yes, correct. Pi over 180. So 30 divided by 180, I can cancel this with this. I will get what? Pi over what? 6. Pi over 6. Pi over 6. So the angle is pi over 6. My angle is pi over 6 radian. Now I can solve the question easy. So S equal R times theta. So R times theta. What is my R? My radius is 10 times the theta pi over 6. And the answer is 10. The answer is 10 over 6 pi. And I can simplify a little bit. So I can get, by dividing both sides by 2, I will get 5 pi over 3. So this is my S. Now what is my R? I mean the area. The formula is like here. This is my formula. It is 1/2 times r squared times theta. So here 1/2 times r squared times theta. So the answer is 1/2 times the radius square. The radius square is 10 times 10, 100 times the theta. The angle here is pi over 6. Must be in radian, pi over 6. So what is the answer? 100. So here I get 100 times 1 is 100 times pi is 100. 100 pi. So here I can get 100 pi over. So here I can get 100 pi over 12 because 2 times 6 is 12. I can simplify it by dividing both sides by 2. I will get 50 pi over 6. Also, I can divide both sides by 3 by 2 again. If I divide by both sides by 2, I will get 25 over 3 pi. And this is my final answer for this question. Thank you, Bilal. This is correct, 25 pi over 3. Okay, any question for the area and the length of a circular arc? This is the area, this is the length, this is the angle. The angle must be in radian, must be in radian. You cannot plug the theory. If you plug the theory, you will get 0. You cannot plug the theory. Okay, no questions. Let's go to the section 5.2. Is easy section called talking about trigonometry of right a triangle. So here 5.2. Of right triangle. Okay, suppose I have, so in the first things in this section, start talk about the trigonometric ratios. So the trigonometric ratios come from a right triangle. So trigonometric ratios come from a right triangle like this. So suppose I have a right triangle. Here is my triangle. This side, have another side. The last one is like this. This it's a right triangle. Why? Because the angle here it is 90 degree. This angle is 90 degree, and this angle it's a acute angle theta. The this side of this angle called the opposite side. Opposite. And this side for this angle called adjacent. And this side to this angle called hypotenuse. Hypotenuse. Okay, now I can define 6 trigonometric ratios. The first one is the sine function, sine of theta. What is the sine of theta? Have you heard about these things? Can you give me the definition, the formula for the sine by using this triangle? Did you hear about something? Jennifer, here you go. Anyone can remind me what is the meaning of sine of theta? Or did you hear about this? I mean, so the sine of theta always equal the opposite side over the hypotenuse. Yeah, this is equal opposite over this one. Now, what is the formula for the cosine for this angle? Cosine angle, what is that equal? It's equal the adjacent over the hypotenuse. Over the hypotenuse. Now, what is the tan? Exactly. The tan of the angle is equal the opposite over adjacent. Exactly, Jennifer. Opposite over adjacent. Now we're going to take the reciprocal of the sine. It's called the cosecant. Cosecant. Here, number 4. 3, 4. Cosecant of the angle. It's the reciprocal of the sine, 1 over sine. And 1 over sine equal the hypotenuse over the opposite. Now, the reciprocal of cosecant is called secant. Like this, secant angle. And the secant angle equal 1 over cosine. And this is equal hypotenuse over adjacent. And the last one is number 6, is the cotan, the reciprocal of tan. Cotan of theta equal the tan, 1 over tan of theta. And this is equal adjacent over this, adjacent over the opposite. Okay, any question for this 6 ratios? This is very important. 1, 2, 3, number 4, number 5, and number 6. This is what you have to memorize. Sine, opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tan is opposite over adjacent. Cosecant, it's 1 over sine, the reciprocal of sine. Secant, 1 over cosine. Cotan is 1 over tan. And you have to flip both, all of this. This one for the cotan, this one for the secant, and this one for the cosecant. Now let me give you example for closing to this ratios, trigonometry ratios. So the example is, so the question is, find the trigonometric ratios if the cosine of the angle is 3 over 4 by using the okay. So here we're going to use the main idea is the Pythagorean theorem. This is like hint for this example. So the cosine of the angle is 3/4. Okay. So the angle has cosine is by, so we have to graph an angle like this. Here's my angle. It's a right angle. This is my angle. It's a right angle. So the cosine of the theta, what is the cosine of the theta? This is the theta. This is a right angle. Must be 90 degree. So the cosine of the theta equal what? What's the formula for the cosine? The cosine of the theta equal adjacent over the hypotenuse. So the adjacent is 3. This one is 3. And the hypotenuse is 4. Now they ask for the three geometric ratios. This is mean the sine, cosine, tan, and the reciprocal of these functions. Now, what is the value for this here? What is the length of this? So what's the length for this side from here to here? What is the length? So the length by this, we can find it by the Pythagorean theorem. Pythagorean theorem, suppose this is x, said the hypotenuse square, 4 square. So here by using so before we solve this question, we have to find the value for x. So the Pythagorean theorem said the hypotenuse square, 4 square, equal this side square is x square plus this side square, 3 square. Now we have to subtract and simplify to find the value for x. So 4 square, what's the value here? 4 times 4 is 16. Equal x square plus 9. Now we have to subtract the 9 from both sides. So I will get minus 9 from both sides. Now 16 minus 9 is, what is 16 minus 9? 7. Okay, correct. So the value for x, I have to take the square root for both sides to get the value for x only. So taking the square root for both sides, take the square root, this will be x and this will be the square root of 7. So this length actually is the square root of 7. Now it's easy to find the sine, cosine, and all the functions. So the first one is the sine. What is the sine of the angle? The sine is the opposite over the hypotenuse. It's square root of 7, correct? Over 4. This is nice. Now the second one is the cosine. What's the cosine? Cosine is 3 over 4, correct. It's given, 3 over 4. Okay. What is the tan? Theta. Exactly, it's yes, square root of the tan is the opposite over the adjacent. Square root of 7 over 3, correct. Now, we have to take the reciprocal of all this. Number 4, what is the cosecant? It's the reciprocal of this is 4 over square root of 7. Second one, number 5. Secant is the reciprocal of this. What is this reciprocal of this? Exactly, it's 4 over 3. It's easy now. 4 over 3. Number 6, cotan of theta. What's the answer? 3 over the square root of 7. Correct. Yeah, this is what you should to know about the ratios of trigonometric ratios. And we have something we're going to do it next week. Happy Thanksgiving, everyone. See you next week.